Chapter 12, Sound. Here we have a visualization of what it would look like if you could see the sound waves of this tuning fork, for example. And we'll get into that more later. But as you can see here, we've got areas where they are stretched apart and areas where they're compressed, stretched and compressed, stretched and compressed. And that's kind of how a sound wave would look if you could see it with your eyes. So what is sound? Sound is the human nervous system's interpretation of vibrations that obstruct the eardrum. The eardrum being one of the parts of your ear. A lot of times when people who are hard of hearing or deaf, you've had something going wrong in this region. Sound. So is sound a wave? The answer is yes, sound is a wave. What kind of wave? It is a longitudinal wave. So what are the two visualizations showing us? Well, the first one is sound represented by compressions and rarefactions. A compression is an area like here, like I said, where the particles are more compressed, and a rarefaction is here, where they are more stretched out. Whereas this other visual is the intensity of the waves. The spikes represent areas where it's more intense. Let's talk about the Doppler effect. The Doppler effect, let's imagine that Bob is stationary on his motorcycle. The sound waves emanating from his motorcycle are very regular in their frequency. Jim, over here, would interpret these waves as having the true note, as he would hear it if he was standing next to Bob. However, if Bob is cruising down the road, Bob would be catching up to the wavefronts, effectively compressing the front of the waves. That compression makes them more frequent. A higher frequency is interpreted to us as a higher pitch. Back here, they would be more stretched out. He's driving away. So you actually interpret that as a lower pitch if you were observing from back here. So if you're observing up close as it approaches you, you hear higher pitch. As it goes away, it's lower pitch. Now, the colors I picked were because if light goes through the Doppler effect, we see what we call a red or a blue shift. A blue shift shows that the thing emanating the light is moving towards you. And I'm not saying something's going to turn blue. It's just that the wavelength will be slightly shorter and it will have a slightly more blue look to it. If something's moving away from you, say in space, galaxies, the wavelength will be slightly towards the red end of the spectrum. That's why they call it a red shift, and this is the evidence that most things in the galaxy are moving away from us. I got a couple websites we can look at here. Number one, this is a nice visualization of a stationary object. You see the wavefronts are very regularly spaced. But down here, as the thing moves forward, you'll see that they're more compressed over here and more stretched out there. Now, Mach is a comparison to the speed of sound. So Mach 7, this is short of the speed of sound. But instead, if the item is moving at the speed of sound, they're actually traveling at the wavefront. And that's kind of neat. If you're ever watching things about fighter jets, this little cone that develops is actually, that compression of all those airs actually compresses the water vapor and makes a little cloud right there. And it only happens right when they're breaking the speed of sound. Okay. And of course, if you're going supersonic, you're way ahead of it. This sonic boom, as you hear, is all the wavefronts crashing down on you at once because they're so compressed. It's very loud. All right. It's neat stuff to investigate if you're interested in it. Then, if you want to see an interesting video that I think helps explain the Doppler effect better, go into YouTube, put in the Doppler effect. Here's the website if you'd like to look it up, and watch it. It's 2 minutes. It's a nice little video that helps demonstrate the Doppler effect. I'm not going to sit here and play it over my video when you can just as easily go look at it yourself. So that's the Doppler effect. And then I have a chapter review for you here. You want to write that down. That'll help you review chapters 11 and 12. Another interesting thing to look at with terms of waves is the Tacoma Narrows Bridge. It's this bridge that collapsed out in Tacoma, Washington, because the wind caused the bridge to vibrate at its natural frequency, and it vibrated to the point where it shook itself apart. So, neat stuff for you to look at.